Hello, students, and welcome to the virtual classroom again. Hopefully after the last lesson, you began to feel like the work you were doing was a bit repetitive and tedious, and that's exactly what you should have felt, because back in the day, mathematicians were doing this work and they're like, feels like we're doing the same thing over and over again, but just with different numbers. Surely there should be a formula we could construct to do all this work for us. And that's exactly what they came up with. And it's called, for lack of better creativity or imagination, it's called the quadratic formula, because it's the formula you use to solve quadratics. Okay, so I'm not going to resolve this entire quadratic with factoring like the previous unit, because it's going to take too long and I can't write in that small of a space, and it was meant to be kind of a review. So I do want you to pause this video and see if you can do it. I'm just going to recall what we do. I'm not going to go through the entire thing. Okay, so to solve this one with getting exact values without punching values into our calculator or reading it off a graph and having to get rounded off numbers, you would move that 2 to the other side. Right. You would then complete the square. And then you would rewrite it like this. And then you would multiply everything by 2 again. And then you would find a common denominator with those two fractions, and you would add them. And then you would end up getting something like this, where you would get 2x plus 7 over 4 squared minus 41 over 8 equals 0. And then once you have there, you could then solve. And how you would solve is you would add 41 over 8 to both sides. You would then divide everything by 2. And then you would take the square root of both sides, because you have now isolated your square. And we don't have to worry about the plus or minus for this left-hand side, because we already know it's the positive version of that bracket, because we can see what it is, because it shows what's inside the brackets that's being squared. But for 41 over 16, we have to take the positive or negative value of that. So the square root of 41 is positive or negative the square root of 41 over the square root of 16, which is plus or minus 4. And then we would subtract 7 over 4 from both sides. And we would get that x equaled negative 7 over 4 plus or minus the square root of 41 over 4, which could then be combined into this. And then we would, to find out the exact value of the two x's, we would go negative 7 plus the square root of 41 divided by 4, and negative 7 minus the square root of 41 divided by 4. And that, if we did it in our calculator, we would get an approximated rounded off answer. And if we were to leave it for exact values, we'd actually just leave it the way it currently is. So surely there is a way to go from here, or sorry, to get here from the original quadratic, which was 2x squared plus 7x plus 1. Surely there's a way to go with these values that are in the A, B, and C position and figure out how to get to this without having to do all that work. And there is. And again, it's called the quadratic formula. Now I'm going to derive it for you now, and I'm going to derive it for you by putting instead of numbers in the A, B, and C position, I am going to put an A, B, and C into the A, B, and C position. And I'm going to go through that method I just did, but with letters instead. I'm probably going to run out of room because I'm writing on my screen with my finger. So I'm going to probably make a new page, but I was able to fit it on my paper when I was doing this with just pencil. Okay. So the first thing we're going to do is we are going to not write in highlighter, not write even more in highlighter. We are going to move that A, whatever it is, out of the way by dividing everything by A. That's going to leave us with x squared plus b over ax plus c over a, and then that placeholder is just hanging out over there. We're then going to complete the square. To complete the square, we have to take half of b over a, which is b over 2a, and then we have to square it. So it's going to become b squared over 2a squared, which is 4a squared. And we have to subtract the same thing because, again, we're just manipulating here, and we don't want to actually change the value because then we're not actually solving. We're then going to write this as a perfect square. So that becomes x plus b over a over 2a squared. Remember, it's half of that middle term or the square root of the third term. And then it's minus b squared over 4a squared plus c over a equals 0 over a. Now, at this point of our solving, we multiply everything by a. So we get a, that's an a, x plus b over 2a squared minus b squared over 4a plus c equals 0. Okay. And that would be where we would solve it. We could try to combine those two fractions, but eventually we have to solve and isolate this. To solve it, we have to isolate this square so that we can then square root both sides. So I'm going to do that now. So in order to do that, I'm going to add b squared over 4a, and I'm going to subtract c. And I'm going to do that to both sides. So I'm going to get a times x plus b over 2a squared equals positive b over 4a minus c. There's more than one way to derive this too, by the way. I'm then going to divide everything by this a, because I need to get this a out of here. So I'm going to be left with x plus b over 2a squared equals b over 4a squared minus c over a. And now I finally have to do something with those two fractions. I need to have a common denominator. So I'm going to multiply this fraction by 4a over 4a, because of course 4a divided by 4a is just 1, but I'm again being a manipulator to create a common denominator between those two fractions, between this fraction and this fraction, so that I can combine them. So that's going to give me, let's see, x plus b over 2a squared equals b squared over 4a minus 4ac, sorry, so a squared over 4a squared. And now I can combine those two things. So again, x plus b over 2a squared. I don't know why I put the squared there, because I just felt like it, squared, equals b squared minus 4ac over 4a squared. I can now square root both sides. Okay. So this is going to be x plus b over 2a equals plus or minus the square root of b squared minus 4ac over the square root of 4a squared is 2a. Okay? And technically it's plus or minus 2a as well, but we already have the plus or minus on the top. So if the bottom was negative and the top was positive, there's both versions are still accounted for. Okay. Now I'm going to subtract b over 2a from both sides. And I'm going to get that x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And I don't know if you've noticed this, but every time you do this, you end up with the same denominator, and you're like, how'd that happen? And it works out that way. So x is going to equal negative b plus or minus the square root of b squared minus 4ac all over, or all divided by 2 times a. And that is the quadratic formula. Will you be asked to derive that for me in Pre-Calc 11? No. Will you be expected to use it and be able to use it? Yes. So x is going to equal negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so if you remember, we had this answer right here from the very beginning, So let's just practice using that. So the number in the A position is this 2, okay? So our A equals 2. Our B equals positive 7. And remember that the sign directly preceding the term stays with the term and is incorporated in that A, B, and C value. And our C value is a positive 1. Okay. So if we use the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac over 2a, we then plunk our values in. So we're going to substitute our values in. So it's going to be x equals negative b, so b is 7. If it was a negative 7, it would have to be negative 7, which would become positive 7. So please remember, when you substitute into brackets, especially when they're negative values. B is 7 squared minus 4 times a, which is 2, times c, which is 1, all over 2 times a, which is 2. So x equals negative 7 plus or minus the square root of 49 minus 8 over 4. So that means x equals negative 7 plus or minus the square root of 41 over 4. And I'd like you to just have a pause and recognize the awesomeness that this is exactly the same thing as we got up here doing that longer method. And all we had to do was substitute the values in the correct place. So, turning back to our notes here, because I went off on a little bit of an aside, now you can use the quadratic formula to solve these answers. I'm not going to do both of these just because of time and don't want a super long answer, but I'm going to put the answers up and hopefully you can get them. So I want you to pause the video here and try this using the quadratic formula. So a equals 3, b equals 5, and c equals negative 2. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And now you're going to put the values in the right place. So a equals negative b, so negative 5 plus or minus b squared, which is 5, so that's 25, minus 4 times 3 times negative 2, all over 2 times a, which is 3. So x equals negative 5 plus or minus the square root of 25 minus 4 times 3 times negative 2. So that will be 25 plus 24 over 2 times 3, which is 6. So x is going to equal negative 5 plus or minus the square root of 49 over 6. And now you're almost done. So if you need an exact value and that square root wasn't a perfect square, like 49, you would just simplify the radical with the coefficient and the denominator for both instances. But here we can actually do, because 49 is a perfect square, we can actually get an exact value without having to round off. Okay. I don't know how many times I can hit the wrong button, but I'm going for a record. So x can equal negative 5 plus the square root of 49 over 6. So that means it can equal negative 5 plus 7 over 6, which means negative 5 plus 7 is 2 over 6, which means it could equal 1/3. So that is one possibility for x. X can also equal negative 5 minus the square root of 49. And then all divided by 6. So it can equal negative 5 minus 7 over 6, which means it could equal negative 12 over 6, which means it can equal negative 2. And here are your two values of x. Isn't that exciting? I know. All right, so the next one, you put the values in the right place. You should end up with x equaling negative 3 plus or minus the square root of 73 over 6. No, you cannot, do not do this. Don't do that. No. You need to have a 3 here as well to do that. And just no, don't do that. We've already talked about that. It makes a baby cry. And remember who the baby is? It's me. Okay, so this is it. 73 is a gross prime number, so it can't be done any further. So if it was asked for the exact value, this is your answer. If it asked you for a value, you could then plug it into your calculator and you will get negative 0.92, and you'll also get 1.92 as your two values. Okay, so there's two possibilities there. Remember to read the questions carefully. When we ask for exact values, there's no plugging into your calculator and rounding off. If you round off, it's no longer an exact value. Okay. All right, so we're just gonna go to the next section of the notes. Apparently, there we go. Here it says, you know, this is a quadratic, but you have to manipulate it first. Okay, so the first thing you're going to do is recognize that this doesn't equal 0 on one side. In order to use the quadratic formula, you have to move everything to one side so that your trinomial with ax squared plus bx plus c equals 0. It has to be in that formula for you to pluck out the a, b, and c values and plunk them into the quadratic formula. So the first thing we're going to do is manipulate this, or we're going to use some algebra, and we're going to move it all to one side. So we get 9x squared plus 12x plus 4 equals 0. And now we have our a value, our b value, and our c value. So now we can plunk those into the formula of x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is 18. Okay, So this is going to be x equals negative 12 plus or minus the square root of 0, which is 0, over 18, which means I didn't give myself very much room to write this, which means plus or minus 0, you don't have to worry about that. So the answer is x is equal to negative 12 over 18, which means x is going to equal negative, and they're both divisible by 6, so negative 2 over 3. And it only has one solution in this case. So you can do the same thing for the next one. You can move everything to the left side or everything to the right side. There is no right or wrong in that. I like to have a values that are positive where I can, but if you move it the other way, it's still going to work out to give you the same answer. So I'm going to subtract 7x from both sides, and I'm going to subtract 1 from both sides so that I get 5x squared minus 7x minus 1 equals 0. That means if I'm putting it into that means my x will equal negative b. So negative 7 is positive 7 plus or minus the square root of negative 7 squared, which is 49, minus 4 times a, which is 5, times c, which is negative 1, over 2 times a, which is 10. Okay. So I'm going to then simplify. So my x is going to equal, and so remember it was negative b, so it's the same thing as negative 7. So that's why it became a 7 there, just to really nail that on the head. We're going to have 7 plus or minus the square root of 49 plus 20. That's a negative and a negative here. And you can't see me pointing, but there's a negative and a negative, which makes a positive. So it's going to be 49 plus 20, which is the square root of 69 over 10. And now you have two solutions. You can have x equals 7 plus the square root of 69 over 10, or you can have 7 minus the square root of 69 over 10. Those can't be further simplified because 69 is not a perfect square. So if you were to put them into your calculator though, you would get 0.13 and negative 1.53. So it depends on whether the question's asking for an exact value or just an answer. And again, even though you could have done it the longer way, and rounded off your answers, it's best to do the rounding off at the very, very end. And that's what's great about the quadratic formula is you're not rounding anything until the very, very end. So you maintain precision up to, but not including the final answer. So this question here, what I wanted you guys to do at the end of this is to just practice all the different strategies on how to solve a quadratic equation. There are 4 ways you can solve. You can graph it manually or with technology. You can factor it. So if you can factor it and find the answers that way, you can complete the square, which is the longest way, but it is if you don't remember the quadratic formula, it's the way you're going to have to go if you want an exact value. And then there's the quadratic formula. So this one you can actually solve all 4 ways. Okay, I want you to pause the video here and try all 4 ways of solving this one. So to solve this by graphing, I'm going to solve this manually. Not manually, I lied. I'm going to solve it with a graphing calculator. So that should pop up there. And I'm going to enter the calculator, the equation in. So I'm going to go y equals, and I'm going to go 6x squared minus 14x plus 8. Again, you could use Desmos as well instead of the TI-83 graphing calculator app. But again, you will not be able to use that on an assessment in a regular classroom. So you should get to use and get to know how to use a TI-83. And I'm going to graph it. I'm going to, it looks like they are very close together or there's only one solution. So I'm going to go to my window and I'm going to change that to -5, 5, -5, 5. I'm going to try that again, see if there's a difference. Ah, there is a difference. So on my x, oops, not zoom, my x max, I want to actually just be like 2 and go to like maybe -1. See if I can see that a little bit better. Ooh, yeah, look at that. All right, so now to find my x-intercepts, I go to the trace. I want my zeros, so I'm going to go left bound. I'm going to hit enter. I'm going to go right bound, enter, hit enter, and it's going to tell me my first 0 is at where x equals 1. I don't think you can see my other screen, but I wrote it down on my notes. I'll come back to that screen again in a second. So then I'm going to go second function trace again. I'm going to go to 0 again, and now I'm going to do the x-intercept on the right. So I'm right bound where I'm under, left bound when I'm above. Hit enter, and I've got 1.333333 repeating. So that's the same thing as x equals 1.3 repeating, which is the same thing as 1 1/3 or 4/3. So I'm going to pop back to my notes so you can see how I wrote that down for number 1. So there's me graphing it. Yay, I solved it by graphing. Wasn't too painful, except for if I didn't know that 1.3 repeating was the same thing as 4/3, and I just rounded it off, I would maybe not, I would lose precision and I wouldn't have an exact value. The second way is to solve by factoring. 6x squared minus 14x plus 8 equals 0. They're all divisible by 2. So that will become 3x squared minus 7x plus 4 with a 2 on the outside. And so now I'm looking for two numbers that multiply to positive 12 and add to -7, and my values are going to be -4x and -3x, which means I'm going to have, I'm just going to ignore my 2 there for a little bit and just do the inside stuff, and I'll write it down at the end. I just hate having to write it each time because that's how I roll. So that's going to be x, 3x minus 4 minus 1, 3x minus 4 equals 0. So I have 3x minus 4 and x minus 1 equals 0. And of course, there's that 2 in front, which really doesn't factor into my solution at all. So if I'm still solving, kind of making a bit of a mess here, I now have two possibilities. I can have this equal to 0. So if 3x minus 4 equals 0, add 4 to both sides. Divide both sides by 3, and I have x equals 4/3 as one of my solutions. I also have this as a possibility of equaling 0. So if x minus 1 equals 0, I add 1 to both sides and I get x equals 1. So there I go, I've solved it, and look at that. Same answers I got by graphing. All right, now, here's the completing the square method, which can be the most tedious, but I actually like it a lot. But it's the best one to use if you don't have the quadratic formula and if you need exact values. So you're going to divide everything by 6. You get x squared minus 14 over 6x plus 8 over 6 equals 0 over 6. I'm going to complete the square. And you're going to have to do half of 14 over 6, which is 14 over 12, and then you're going to have to square 14, which is 196 over 12 squared, which is 144. You're gonna have to subtract that as well. Not forget that. You're then going to multiply everything by 6. Oops, I skipped a step. Oopsies. Oopsie doopsies. I have to finish doing that. This first, and then it was minus 196 over 144 plus 8 over 6 equals 0 over 6. And now I'm going to multiply everything by 6. My apologies. Got to finish completing the square. Very cheeky of me. And that is times 6, not to the power of 6, in case that was confusing how I just wrote it. It's times 6. So that's going to give me 6 times x minus 14 over 12 squared minus 196. So if I want to multiply it by 6, it means I divide the denominator by 6, and I get 24 plus 8 equals 0. Okay. I then have to simplify and add my fractions. So I'm going to do that next. This becomes 6x minus 14 over 12 squared. 24 and 196 are both divisible by 4. So this becomes 49 over 6. If I want 8 to also be over 6, I have to multiply 8 by 6. So that becomes 48 equals 0. So I get, this is a good one, 6 times x minus 14 over 12 squared minus 1/6 equals 0. I'm then going to add 1/6 to both sides. I don't know why I picked 6 because I have a really hard time saying that word, but no judgment here, right, guys? Yeah, sure. Equals 1/6. Okay. We are now going to divide everything by 6. So we're going to get x minus 14 over 12 squared equals 1 over 6 divided by 6, the same thing as multiplying the bottom by 6. There we go. Now we're going to square root both sides. And we're going to get x minus 14 over 12, I didn't mean to stay in red, but there it is, plus or minus the square root of 1 over 36, the square root of 1, which is 1, over the square root of 36, which is 6. I'm then going to, not do that. I'm then going to add 14 over 12 to both sides. Now I'm going to get x equals 14 over 12 plus or minus 1 over 6. And I can simplify 14 over 12 to 7 over 6. Plus or minus 1 over 6. And now I have two possibilities. 7/6 plus 1/6 is 8/6, which equals 4/3. There we go. I also have, if x equals 7/6 minus 1/6, it equals 6 over 6, which is 1. And here we go, we got the same results. Isn't that lovely? Yay, so that was method 3 by completing the square. Now the last method, method 4, is the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac over 2a. So negative b was negative 14 plus, why did it look like that? Negative 14 plus or minus the square root of 14 squared minus 4 times a, which was 6, and c, which is 8, all over 2 times a, which again was 6. So that's just me putting the values in the right place. So x is going to equal 14 plus or minus the square root of, it's going to end up being a 4, divided by 2 times 6, which is 12, which means x is going to equal 14 plus or minus 2 over 12. So we're going to then go through the two possibilities. 14 plus 2 is 16. 16 divided by 12 will simplify to 4/3. 14 minus 2 is 12. 12 divided by 12 is 1. And here we go. We got the same results. So we just took one trinomial and solved it in 4 different ways. Now, obviously, this trinomial lended itself really well to being graphed or factored, and those were faster methods for this particular trinomial. But which method do you prefer and why? You don't have to answer it, just think about it. When would you use one method over the other? For this particular trinomial, which do you think was the best method to use and why? Let me know your thoughts on that. What we're also going to do is you guys are going to do these questions right here, all right, from the textbook. Let me know if you have any questions. I hope you guys have found that helpful. Have a great day.